So you saw yesterday, I tried to start introducing you slowly into like this man method. Okay. And then we'll look at a little bit of expansion too. Okay, this is the same expansion that we've been doing. Okay, so far we're going to look at we've been doing a little bit of factoring, but now we're going to concentrate on something a little bit more specific in terms of the factoring. Okay, and trinomials. The word trinomial means the prefix tri means 3. Okay, so this whole thing here means 3 terms, which we saw this morning as being something like x squared plus, well, as ax squared plus bx plus c, right? 3 terms, individual, where a, b, c are just numbers, okay? So we've seen this before, and you're going to do some work, or you're going to submit a quiz today on how to graph the parabola in that form, okay? That's what we called standard form. Okay, that's what we've been dealing with, okay? And then we saw how to work with this a little bit yesterday and how to build those things, okay? This morning, and some of yesterday, we saw okay? We saw common factoring this morning, okay? This afternoon, we're going to factor
I'd like to reschedule under the circumstances. Okay.
Okay. We're going to factor trinomials this afternoon, okay? And the key with this is trinomials, the word tri again, means there's 3 terms always, okay? Again, this is in your minds online, okay? If you guys want to print it out or whatever, okay? It's sitting in there, blank copy. Okay? So here's the catch to this whole lesson, okay? It's going to require on your multiplication tables, okay? That's what we need. Okay? You're going to have to be able to like multiply a little bit in your head. Okay? So here's the game that we got, okay? We need to find 2 numbers that sum, remember the word sum is add, and the product is, okay? So our game is, can we come up with 2 numbers that add to 15 and multiply to 36? Okay? So I want you guys to take a sec, okay? The way I typically like to do this is I make like I always start with the factors. Okay, so like the 2 numbers that that multiply. So what I like to do is figure out, like for instance, I'll write it over here. So for this one, I need 2 numbers that multiply to 36, right? That's what I'm interested in. So I'm going to go, well, 1 times 36 equals 36. If I add these 2 numbers together, that does not equal 15, right? Well, that's a problem. So we've satisfied the product, but we haven't satisfied the 15 yet. Okay, so that's not, it's a problem, but it's not a problem that we can't fix. So we're like, okay, this one doesn't work. 1 and 36, the 2 numbers 1 and 36 don't work, right, for this one. So let's just go to the next number, 2. 2 times what equals 36? 2 times 18 equals 36. Again, we have satisfied the product, okay, but 2 plus 18, again, does not equal 15. But we're getting closer. All right, so we haven't satisfied this yet. So then we're okay, not a big deal. Try it again. Okay, 3. 3 times what equals 36. Okay, and sometimes you guys might need your calculators for this to get the hang of it, right? Just to check it real quick. 3 times 12 equals 36. Okay, well that means we've satisfied the product. And look at that. 3 plus 12 also equals 15. So the two numbers that work in this scenario are 3 and 12. Does anybody have any questions what I did there? All I'm doing is I always start, I like doing this. This is just, if you try to jump in and get right to that answer, you're gonna have a harder time. What I like doing is just starting at 1, check 1. 1 doesn't work, okay, that's fine. Go to 2. Sometimes things aren't divisible by 2, so you just skip it. Then you'd go straight to 3. Sometimes things aren't divisible by 3, then you'd skip it. You're checking each of the numbers and what you can multiply them by to give you this product, whatever that number is. In this case, it was 36. Okay, and the next one we're going to see it's going to be negative 18. Okay, so again, you just make a different list, that's all, right? But you start at the same spot. 1 times, and the thing that I like doing when I'm playing this game of trying to find the two numbers is at first, at least for the product, I ignore the negative. Okay, I just pretend it's not there because I can make it negative very easily by making one of the numbers negative. Okay, so 1 times 18, well that equals 18. Okay, good. So we've satisfied the product. Is there a way for me to get negative 3 out of this? 1 and 18. I don't think so. They're too far apart. Okay, so we're like, okay, we're stuck. Let's go to the next one. 2. 2 times what equals 18? 2 times 9 equals 18. Again, we've checked. We made the product work, but there is no combination of 2 minus 9 or negative 2 plus 9. It's never going to equal negative 3. Just not going to work. Okay, so we're stuck again. Which again, not that big of a deal, really. We're stuck, but we just keep going until we find something that works. 3. 3 times what gives me 18? 3 times 6 equals 18. Okay, well that checks out the product. But here's the issue. 3 plus 6 equals 9. I need it to equal negative 3 is the issue. It's at this point now that we go, oh yeah, I forgot our number's supposed to be negative. Okay, well that changes things because if either of these two numbers are negative, negative 3 times, that's not 9, negative 3 times 6 is going to be negative 18. Okay, so the negative checks out now. But if I add this together, negative 3 plus 6, that's not equal to negative 3, that's equal to positive 3. Well, that's not a big deal because I can switch the sign, no problem. Right? I can say, okay, well, I can go negative 6 and 3 will work. Right? Negative 6 plus 3 is equal to negative 3. But it's also negative 6 times 3 is negative 18. That satisfies both the conditions. Okay? That one's a little bit harder. Okay, it's harder from the standpoint of we're throwing in negatives, but we'll start easy down at the bottom and we'll work our way up. Okay. Right now, this is just like giving you all the scenarios that you can see. Okay. Does anybody have any questions? Type them in the chat. So right now, we're not really doing anything right now. We're just playing a little game here, right? It's the game that you're going to have to eventually play. But what I'm trying to do is I'm trying to find the numbers that make these two things work. That's the game. Okay, so for this one, we'll do this one in blue. Again, we need two numbers that multiply to 12. So 1 times 12 equals 12. Can you ever get 1 plus 12 to equal 7? Negative 7? No. Not going to work. Okay. All right, well, let's go to the next one. 2 times what gives me 12? Well, 2 times 6 gives me 12. I can't make 2 plus 6 equal negative 7, though. Okay. Well, what about 3? We got to go to 3. 3 times what equals 12? 3 times 4 equals 12. All right, that's not bad. 3 plus 4 equals 7. So we've checked out the product, but here's the issue. I don't have negative 7. I have positive 7. Well, that is an issue, but it's not the end of the world. Because if you do a little bit of thinking, you could say, well, if I made both of these two numbers negative, negative 3 plus negative 4 equals negative 7. But if I multiply negative 3 times negative 4, the two negatives cancel, and I get 12. So now, with these two numbers, negative 3 and negative 4, I have now satisfied both of these conditions. These are the two numbers that work. Okay, does anybody have any questions? This is not easy, okay? This is hard. Probably one of the harder things we're going to do in this course. Because we're just taking our time through it, okay? But again, this comes up in grade 11. Okay, so it's not going to just go away just because you want it to. Okay, we're just playing a little game. We're just trying to figure out these two numbers that work, given two conditions, what the sum and product are. Okay, that's what you want to do. The strategy is exactly this. I just start 1, 2, 3, 4, 5. I keep going until I find the two numbers that work. You just keep going. Okay. Okay. So here's what we got. I'm just going to review a little something here. Okay. Around expansion. Okay. This is ultimately what our answers are going to look like when we get to the bottom of the page. Okay. What I want to show you, I'm just going to kind of interject here, is we saw the word expansion yesterday. Okay. Expansion, remember, we had factoring went in one direction, and expansion went in the other. Okay? So expansion, we used the table. Right? And we just filled in the middle of the table. That's what we did yesterday. X squared, 7x, 3x, 21. Okay? So we said, we just added up. X squared plus 7x plus 3x plus 21. You can clean up the two middle terms. That's what goes in here. Okay? The expansion work, okay, is the table. Okay, this thing. And obviously that doesn't fit in there. There's another way to do it too, okay? For those of you that don't want to do the table, I find this not harder. I find it faster. It's harder to keep track of. It's not as well organized, okay? This is what I call like the rainbow method, okay? And then I just go, so you follow the rainbows. X times x is x squared. That's the first one, the first arch. The second arch is x times 3. Well, that's 3x. But you also have to multiply this one by the other two. So plus 7x plus 21. That looks like this. I just prefer the table now. Okay, I made this sheet a while ago. I just prefer the table method for expansion. This is so organized, right? And it builds off of everything that we've done so far, okay? Remember, expansion is the opposite of factoring, okay? That's how we check our answers. And we're just going to keep revisiting this, okay? I'm just going to keep throwing it in and revisiting it. Do we have any questions? We're just laying the groundwork here. We're going to go down and try some questions here. I'm going to give you the steps on how to do these, okay? And the bigger picture of what we're doing, okay? Okay, so let's go down here. So for instance, I think we're looking at, I'll write this, somehow this got cut off here. I think it was in editing. Here's the equation we're looking at. Okay, this is in your head when you're trying to do these questions. These are like, you're reading through these steps. Okay. You're going to say, okay, we need to determine two numbers that, if we remember from yesterday, we need two numbers that multiply to the last term and add to the middle term. Okay, so we need two numbers that multiply to 36 and add to 15. Remember, see where those come from? That's the game we're playing. So if we go back up here and we look, okay, numbers that add 15, multiply to 36. This is the game. Okay, we're just trying to figure it out. Okay, determine the pairs of numbers that multiply into 36. Okay, because we're talking about multiplication, so we have to talk about the number that it's going into. Okay, these pairs of numbers are what are called the factors. Okay, so here's your steps. Like you're running through these steps. So this is what I was saying above. Just start with the number 1. 1 times 36 equals 36. There is no way you're ever going to make that equal 15. Okay, so we can't use 1. We're going to have to go to 2. 2 times what equals 36? 15. Nope, not 15. 18. Okay, again, there's no combination of negatives or anything that's going to ever equal 15, right? So you're stuck again. So you just keep going until you find two numbers that work or that you can force to work. So 3 times what equals 36? 3 times 12 equals 36. Okay, that's good. Right? That satisfies the product, all 3 of these. Okay? The catch is, when we look at step 2 here, we also need the numbers that we pick from above, or ultimately the numbers that we pick from above, have to add to 15 as well. Okay? And so you just check them. Well, 1 plus 36 does not equal 15. Next one. 2 times 18 does not equal 15. 3 plus, not 2 times 18, 2 plus 18. 3 plus 12 does equal 15. Wow. There you go. There are two numbers, 3 and 12. Okay? To finish off, this is the hard part. Step 1 and 2 are the hard part. It just involves some thinking. Step 3, once you find these two numbers, you get to go like this. And you're done. If you were to expand these, like what I showed you here, if I wrote them in a table, and you expanded it, you'd get the question back. Get messy here. Okay, remember what I'm doing. I'm just adding these up. Okay. So I'd go x squared plus 3x plus 12x plus 36. Collect the 2 in the middle. That looks like our original question. That's how I know I'm right. How you know you're right. Okay, when you start to go do through these questions. Okay, does anybody have any, this is, again, I'm going to say this again. It's not easy. Okay. It does get easier and easier the more of them you do, though. I promise you that. It's like everything else. Okay. Okay, our goal is to make something look like this. I want two brackets side by side with what the two numbers are. That they're the two answers to the game that we're trying to play, okay? And just taking one step further back, keeping in mind this is just another form of factoring. Okay. We saw how to build these things yesterday with the tiles, okay? It's the same thing. Okay, maybe the part B I'll draw as a picture because it's a little bit smaller. Okay, part A I'll do the algebra on, and hopefully my goal is that you guys will see the difference between first of all, the algebra tiles are great from the standpoint of understanding. Their limitation is when you start having to build, when you're going to have to collect 20 cubes. Negative 40 cubes, 36 cubes, and 20 rods. Like, you don't want to be building those things, right? It's going to take you a while. It'll work. 100% it'll work, right? But even drawing that out, like, you're going to have to sit here and draw 20 rods, right? 20 rods and 36 little squares. Like, you don't want to be doing that. That's why we show you this method that we're doing right now, okay? It's a little bit more powerful and saves you time. Okay, so I'll do B just to show you. I want to do A first and then I'll do B, but I'll show you B by drawing the picture. I selected B because the numbers aren't as big. Okay, you could build that one, no problem. Okay, so let's just take a look here. I'm going to try and follow steps 1, 2, and 3, but the first thing that you need to identify is, I always write the man method down on the side. Right? And just like in the word man, the A goes in the middle. Okay? And then the catch is with this is you always kind of spell man backwards. So the M goes over the last one. Okay, so that just means we need two numbers that multiply to 20, but add to 9. Okay, so now we get to play our game. You start writing the factors down. That's n. N is the numbers that work. Okay, all right, well, let's go. 1 and 20. 2 and 10. 3 doesn't go into 20, so you get to skip that one. Right? There's no number. It doesn't work. All right, so skip 3, go to 4. 4 times 5. Well, that looks all right. Right? 4 times 5. 4 times 5 equals 20, but 4 plus 5 is equal to 9. Well, those are the two conditions that I'm trying to satisfy. So these are the two numbers, 4 and 5. Okay? Then if you just look at step 3 is the easy part, this one here, from above. Okay? So just fill in the blanks in the brackets. Okay, well, okay. All you have to do is take the two numbers that worked. In this case, it was positive 4 and positive 5, and you write whatever variable you're working with in front of those two numbers. X plus 4, x plus 5. Done. Okay. This, what we just found, is another version of this. They're the same thing. They look different. The catch is, eventually we'll be able to use this for something else. Okay, but we have to be able to get there first, which is why we're doing this. Okay? Does anybody have any questions now? I suppose I'll ask after I do the next question too, but you can put them in the chat. Okay, as promised, I'm going to draw this next one, okay? So if I were to take a little inventory of, okay, well, I have 1 square, 1x squared square, and then I have 7 rods, and then I have 6 little single squares. Okay, so you got to build me a perfect rectangle with that. So if I were to do that, I draw, there's my x squared, and then I need to include 7 rods. There's 4. And again, a little bit of, the other thing with this method is it involves a little bit of trial and error, especially drawing it. With the tiles actually in front of you, it's not so bad because you can slide them around pretty easily. That's 5, that's why. There's 6, I need one more. Where's it gonna go? Something's not right here, what's going on? Alright, that's not gonna work. Alright, this is what I don't like about this, drawing it anyway. I don't necessarily disagree with the method, I like the method. I don't like it in practice though. Actually drawing these things is a little bit, makes me think. I think I got it though. A little tricky. Okay, here's what you have to draw. I'm gonna get rid of the inventory here because I'm running out of space. You gotta make it look like this. So that made me think, right? I'm not, lie. That made me think in order to get this to work. Okay, but look, if I draw it now, this creates a perfect little rectangle. It's drawn on a curve, but okay. The catch is here though this time. That's a perfect rectangle. I'll contain it for you. You can imagine it being a perfect rectangle. Now you can tell me, remember this is the area. The inside is going to be the area. I want you to tell me what the length and width are. Okay, well it looks like I can lay a rod down here and then 6 ones. Okay, so that's x. This top piece is going to be x plus 6. All right, well, let's go down the other side. It looks like I can put a rod there and then a little 1. Well, that's x plus 1. Okay, I'm going to shrink this down a little bit just because I want to do this question using the method too. Okay, so there's your picture. We just drew that together. Okay, we figured out what the length and width were. That produced the area from the question. This is your area. If I apply the method I just showed you, so I need two numbers that multiply to 7 and multiply to 6 and add to 7, right? Then you can tell me what the side lengths are. This is basically what we're doing. These are the side lengths, length and width, right? So let's go do that. Need to find two numbers that multiply to 6 and add to 7. Well, let's start running through our numbers. 1 times 6. Oh, that's not bad. That's an easy one. That's convenient. Look. 1 times 6 equals 6. 1 plus 6 equals 7. It works for both of them. So, how do I get my answer, my final answer? Well, I just look at step 3 again. It's telling me to put a variable in front of both of them. X plus 6 times x plus 7. That's your final answer. Where else did I see that? Oh, sorry, one sec. Silly me, I'm getting too carried, too excited. It's not x plus 7, it's x plus 1. Because it's the two numbers that I picked. Where else did I see that? X plus 1, x plus 6. Okay, I did this both ways to prove to you what we did yesterday wasn't a giant waste of time, okay? You can build these things. I just don't really want you to sit there and have to draw 36 little squares and 20 rods, and it's just not a good use of your time. I'd rather just look at how easy this is. Or not easy, but small and condensed. Right? More practical, more efficient. Okay? More efficient because you saw how many times I had to redraw this picture. Even with a little one. Can you imagine how many times you have to redraw it doing 36 and 20? Be here all day trying to get that to work. Okay. Any questions yet? Okay, we got a couple more. Same process though. You identify. Remember, you always write the word man backwards on top. Okay, well, you don't even need the n. You just go, okay, so I need two numbers to multiply to negative 40. This is a little trickier this time. And add to negative 3. All right, well, let's start making our list then. I'll make our list over here. Okay. 1 and 40. 2 and 20. 3 going to 40. No, it skips over it, right? So you don't have to do 3. 4 and 10. 4 times 10 works. 5 and 8. Okay, I think we're getting somewhere. Okay, I'm looking at, like, because I've done this enough times, I'm looking at the relationship as I'm writing down these factors. I'm always checking, I'm always looking back here to see, is there something, are they starting to look related in any way? 2 and 20 give me multiple to 40, but they don't really look close enough to give me an addition of -3, right? So I just keep my eye on this list of over here, right? I'm just keeping my eye on these as I'm going through these, right? And I'm seeing if there's a combination. As soon as I hit 5 and 8, I was like, okay, well that looks okay. Like I could work with it almost, right? The problem is, as it stands right now, 5 plus 8 does not equal -3. But it also, 5 times 8 also doesn't equal -40. I need to make it equal -40. Well, how do I do that? Well, I can make either of these two negative, right? And then it would be fine. But keep in mind, if I need to make it -40, then I can make one of these negative, right? So you got to select which one is going to give you an addition statement of -3, right? So if I say -5 plus 8, that's equal to 3, not -3. But -8 plus 5 is equal to -3. So here are your two numbers that work. Okay? As soon as you find those two numbers, that's it, you're done. -8 times 5 is -40. It works. Okay? -8 plus 5 is -3. It satisfies both of these. Once you have those numbers, you just go, oh, this is the easy part. X minus 8 times x plus 3. And you're done. Okay, I don't think I'll do one more with you. Okay, I'll do one of these bottom ones, and then that'll be it for today. Okay, give you guys lots. I want you guys to kind of not struggle, but we'll call it productive struggle, right? I want you to go try these questions, right? Because these are not easy, but they're not going to get any easier if you just sit and don't do anything. Okay, you just try to ignore it. It's not going to happen. Okay, it needs to be a bit of productive struggle, and that's what I'm here for until the end of the day today. Okay, you can stay back and ask me questions or whatever. Okay, this one here. This is kind of a good recap, okay, from this morning to this afternoon. You have no idea how to get this to go, okay, is the issue. Okay, but I gave you a clue here, and I said it at the very, very top of the lesson too. If we go back up here for a sec. Always try to common factor first. This is where we found GCFs from this morning. Okay, so if we go back down to these questions, I'm looking at all three of these terms. There's three terms because we're calling it a trinomial. That's just what this is called. As a package, it's called a trinomial. Okay, now you're looking at all three pieces there and you're saying, okay, what can I divide all three of these by? Same thing, got to be able to do it to all three, right? I'm looking at it, I'm like, okay, well, they all could be divisible by 2, but you could do that, but then you'd have to be able to do it again and then again. You don't want to do that. That's why we're saying find the biggest number that you can divide all of them by. It looks like, and most of the time this will be the case, whatever this leading number is typically what you're going to be able to divide everything by, okay? From a number standpoint. It looks like I could divide them all by 6, right? 24 divided by 6, 30 divided by 6, 6 divided by 6. I think that works, okay? You can't divide it by 12 or whatever, right? Because 6 divided by 12 is going to give you a decimal. That doesn't work. Okay, so you're keeping track of your greatest common factor. Well, it looks like I can divide by 6 so far, right? It also looks like, okay, I'm kind of stuck now because if I'm looking at the rest of the question, there's a P, but there's no P on the end here, right? Which means I'm stuck. I can't take a P out of all three of those because it doesn't exist in the last one, right? So we're stuck. which means, okay, we're in the process of just like kind of simplifying this by factoring the greatest common factor out. So I take my GCF, I write it out front. You guys tell me what's left after you do the work. All right, well, 6 divided by 6 is 1. So you get 1p squared. 24 divided by 6 should be 4p. And negative 30 divided by 6 is just the same thing as saying 30 divided by 6 with a negative on it. 30 divided by 6 is 5 with a negative on it. Okay? If I just get rid of this imaginary 1 that's there, because there's always an imaginary 1 out front, you can write it in. Now this looks like something that we just finished doing. Okay, you can go to here now and say, okay, I want to find two numbers that multiply to negative 5, add to negative 4. So you start your list. Okay, and you start running through them. One, 5. You can't do 2. 2 times nothing equals 5. 3, it's not going to work. There has to be a combination of 1 and 5 there that works. So then you start checking. You're like, okay, well, I need it to be positive 4, but it needs to multiply to negative 5. Well, that sounds like 1 times negative 5 gives me negative 5. But 1 plus negative 5, that's negative 4. That doesn't work. You need to equal positive 4. So all you have to do is switch the negative. Negative 1 and 5. Okay, once you have that, you say, okay, I'm just going to, that replaces, you go p minus 1 times p, and you're done. Okay, that's a combination of both. Okay, so for now, I would try and spend a whole bunch of your time up here. It's okay if you don't get down here yet. Okay, I specified some questions too. I think on. Well, I gave you some this morning, but you could honestly pick any of those, but don't just do 3 or 4. Like maybe try doing 6, 7, 8, 9, 10 of them. Okay, you don't have to do the whole alphabet. There's almost 26 there, but not quite. Okay, but do as many as you can until you feel comfortable. Okay. We can spend a little bit more time combining the two tomorrow, okay, looking at part B. But it's very, very important to be able to do these questions because I can't take you any further until we get this down. Okay, this is important. So I need you guys to try some questions, get some productive struggle in. If you don't have productive struggle, you don't reach the points where you're gonna you don't know what to do. And so when they come up, you're still not going to know what to do. At which point, if that point is on the test, I don't know what to do. I don't know what to tell you. Right? I can't help you then. I'm telling you right now, everybody's going to have to try these questions. This is not an easy concept. Okay, it's going to take some time. It's going to take some time and some help. Okay? This went disastrously for me in grade 10. Partially because I never got shown the fact that I could build this thing. I need an x squared, right? And then 3 rods. And 2 little singles. Okay, well, I've built my perfect rectangle now. Read off the side lengths. X plus 2. X plus 1. Right? If I were to draw them on here. There's a rod and a single. X plus 1. There's your answers. You just multiply them beside each other. Okay, I know those are the answers because I come down here and look. There's the answer for 2A. So the other thing you guys have available to you here and it might make your life easy to at least try as many of these as you can, like this whole top section, is if you go down and look at the answers, you know what kind of the two numbers are supposed to be. You can use this to help you if you're stuck. The important part is that you guys work through these 3 steps and struggle with them a little bit. Okay? And then producing these answers. This is what's important. Okay? It's now 1:53. That'll be it for today. Okay? Quadratics is a hard unit. Okay? You guys need to try some things and ask some questions where you need help. Okay? Nobody's expecting you to get this right out of the gate, especially if we're not in face-to-face, right? So all I can do is offer the help. I can't force you to do it, okay? But I'm telling you right now, it's not going to go away. You're going to struggle with it now, and you don't deal with that, you're going to struggle with it in grade 11, okay?